Okay, this is the last section of chapter 11. Last section of chapter 11, which should intuitively make sense, is proportion. Because we've done mean twice already, haven't done proportion yet. So this section is going to have phantoms and panic for proportion. We will do a full phantoms in class. I will give you the formula for panic, and then you're on your own for that one. I will tell you for your homework, you have 2 problems, 1 phantoms, 1 panic. So it is, I would argue, shorter than the other homework assignments you've done. So just 2, 1 phantoms, 1 panic. Before we start, I think I told this to you, but I want to say it again. There is no matched pairs for proportion. Matched pairs is only for mean. So as soon as you see the word proportion in a problem, you know that we're not talking about matched pairs. So this is the example that we're going to do. During the 80s, approximately 22,000 physicians over the age of 40 volunteered to participate in a long-term health study, for which one important question was to determine whether aspirin alters the rate of heart attacks. The physicians were randomly assigned to the aspirin or placebo group. The results below are for a specific subgroup of the volunteers, specifically the men aged 50 to 59. Determine whether there was a significant difference in the heart attack rates for the 2 groups. Okay, rate, that's just another word for proportion. That's just another word for proportions. That's how we know that we're doing proportion. We have 2 proportions here because we're looking at the heart attack rate in the aspirin group and the heart attack rate in the placebo group. So let's jump right in. We have 2 samples, so we're going to need 2 parameters. Symbol for population proportion is P. So I'm going to say let P1 be the population proportion of heart attacks for men 50 to 59 who take aspirin. And then P2 is going to be the population proportion of heart attacks for men 50 to 59 who take a placebo. So we are not just referring to these men, we are referring to all men 50 to 59. So that's what P1 and P2 are. Heart attacks for all men 50 to 59. For our null, per normal, we're going to assume that there's no difference in the heart attack rates. So I'm going to assume that P1 is equal to P2. And we want to know, is there a significant difference? So we want to know, is there evidence that P1 is not equal to P2? So this is how I showed you before to write the null and the alternative. As a reminder, this is another way, and this is how you're going to see it written in the book. So I don't care which notation you use, the blue or the green, but just know that you could see it the other way as well. Okay. First assumption, always. Random. What does random mean in this context? Assignment of treatments. This is an experiment. Was sampling done in this case? No, because they're volunteers. There was not sampling done. These were volunteers. It's an experiment, so treatments need to be randomized. So are the treatments randomized? Yes, that was stated. Anybody? Independent samples. So I'm going to write this down. If it's an observational study, your samples need to be independent. So in this case, unnecessary, because there wasn't any sampling done. But just know if it was an observational study, you would need to check that the samples are independent. Here we don't need to do that.
When we're writing, do we have to say like it's not necessary?
No.
We just not have to.
Just don't put it at all. Approximately normal sampling distributions. How do we check that for proportion? Yeah, n times p. So there's two ways you can write this. You can either write approximately normal sampling distributions using plural, of course, because we're checking for both, or it's also labeled as large samples. Bless you. Either one of those is sufficient. I don't care which wording you use, pick one or the other. Please make sure it's plural, though, so I know that you checked for both. Okay, this is going to be a little bit of a throwback, so I'm going to need you to dig back in your brain. When we did a phantom for one proportion, we did n times p is greater than or equal to 10, and n times 1 minus p. Where did we get that p from? Is it safe to say maybe we want to write this down? I'm going to just write this off to the side. Okay, when it was a one proportion for phantoms, we did n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. And I don't know if we remember this, but when we did a panic, so when we did a confidence interval for one proportion, we didn't do n times p, we did n times p hat. And we had to use p hat sample proportion because we didn't have p. So in phantoms, where did we get p, or where did we get an estimate for p? The null. The null. That came from the null. But for a panic, we don't have a null, we don't have an estimate for p, so we use p hat. If we use that same idea here, n times p, is that going to work out for us? Do we have an estimate for p1 and p2? No. Okay. So in this case, even though it's a phantoms, we're going to have to do n times p hat. And it actually has to be done for both groups. So that is what I think is really hard to remember, is when it's one proportion and it's a hypothesis test, you use p. Every other time you use p hat, though. Okay, so p hat is the heart attack rates. In our first group, our aspirin group, we're going to have to do a little bit of adding to figure out what our sample size is for both of them. Can you guys do that, please? $37.25. Does that? Thank you. Okay, so for our aspirin group, our sample size is 3,725. Our heart attack rate is 51 out of 3,725. And then for our other sample, the placebo group, our sample size is the same, 3,725. This time, though, the heart attack rate is 87 out of 3,725. Don't do extra work here. This works out so nicely. Those cancel. When we get 51 is greater than or equal to 10, which is true. In this case, we get 87 is greater than or equal to 10, which is also true. You cannot stop there. You have to check the other one as well. So then I have to do 3,725 times 1 minus 51. And I will just tell you that ends up being 3,674. Over here, same thing. That ends up being 3638. So that tells us that both sampling distributions are normal, or that both samples are large. Again, either one of those vocabs is okay. %% rule. Normally you would check unnecessary here because we have volunteers. These men volunteered, so we do not need to check the 10% rule. But if it was a sample, an observational study, a case where sampling was done, you would check the 10% rule. What's nice about phantoms as compared to, oh no, mean is the same. What's nice about proportion, I was going to say, for a panic, the assumptions are the same. So these assumptions are going to be exactly the same when you do the panic. Any questions right now for me before we keep going? Greta.
Like if we do the 10% rule or something when it's not necessary, like,
what happens?
Yeah.
For the AP test, nothing. Right now, historically, the AP test really has not cared about the 10% rule. So if you don't check it and you need to, it's not going to count against you, at least historically. For me, if you check the 10% rule and you don't need to, I'm not going to do anything about it unless you've done it poorly. So like if your context is wrong or bad and it's just not done well, then I'm going to take off. Otherwise, I'll just ignore it.
Okay, thank you.
Yeah. Okay, so let's keep going. For N, this is called a two-sample hypothesis test for proportion. This is two-tailed. We're going to use alpha as 0.05. And then remember, proportion uses Z. There's no degrees of freedom. So while mean uses T, proportion uses Z. Did I forget anything for N? Okay, I'm going to assume no. Okay, I'm going to be honest with you. The formula, pretty rough, okay? Just going to tell us straight off the bat, the formula for phantoms is rough, and here's why. You're going to have your fraction Z equals. It's going to be P1 hat minus P2 hat minus P1 minus P2. That should follow pretty similar to mean. Here's where things get tricky. The denominator is a huge square root. If you remember from phantoms or panic for proportion, it's the P1 times 1 minus P1 over N1. Okay, this is going to be similar, except this is PC hat 1 minus PC hat over N1 plus PC hat 1 minus PC hat over N2. So you should be like, hey, what the heck is PC hat, right? Okay, I'm sorry to tell you, PC hat is then another formula. It's N1 P1 hat plus N2 P2 hat over N1 plus N2. I know, it sucks, okay? That's just how it is. Remember on the calculator when we did two-sample tests for mean and you got down to the bottom and the calculator asked you, is this pooled? This is called a pooled standard deviation. You don't need to know that, but it's a fun fact for you. That formula is on your formula sheet, so at least you have that going for you. Okay, so let's use this one. Obviously, you're going to have to find PC first before you can find Z. So our first sample size was that 3,725, and then this is 51 over 3,725. And then the second sample, 3,725 over 87. Those are the right numbers, right? 51 and 87? Okay. So then we have 3,725. Okay, it is incredibly important that you use the exact value. Do not round this value, particularly since it's so small. It ends up being 69 out of 3,725. If I were you, my suggestion would be that you store this value in your calculator, because in your formula you're going to use it 4 times. So then our z, now doing all of that, we get 51 out of 3,725 minus 87 out of 3,725. This P1 minus P2, that comes from the null, so we're assuming the difference is 0. And then our denominator, 69 out of 3,725, 1 minus 69 out of 3,725 over 3,725, plus, that's just the first fraction. Again, 69 out of 3,725, 1 minus. I think it's fair to say we need to make sure we can actually put this in our calculator. So right now, we're going to take a minute, put that in your calculator, and get a test statistic, please. So like I said, take 2 minutes, try your very best to draw the figure, and to come up with the p-value, please. Here's what I got for my figure and my p-value. The entire denominator is the standard deviation of 0.003. Remember that it's a two-tailed test, so based on our test statistic, we're finding the probability less than that value and then multiplying it by 2. In your calculator, you should have done normal CDF. So we get a p-value of 0.002. How did we do? We did pretty good? Okay. So in this case, 0.002 is less than 0.05, so we are going to reject. Based on my analysis, I reject the null. And believe there is a difference in the population proportion of heart attacks. In parentheses, I'm going to write heart attack rates. And I'm doing that because that's specifically the wording that the question used. So I believe there is a difference. I forgot the word proportion. Population proportion of heart attacks, or the heart attack rates, for men taking aspirin and placebos aged 50 to 59. So then for the p-value, 0.002 is the probability of obtaining a difference in sample proportions of, I don't know, I actually have to calculate it. Of negative 36 out of 3,725, or more extreme, assuming no difference in the population proportion of heart attacks for, can I just say ... and you can fill in the rest of the context? Are we okay with that? Okay, like I told you starting out, this one's a doozy. That being said, this is by far the worst procedure, in my opinion, because of the PC. Two pieces of good news. The first one is that Panic does not use PC. It's only the Phantoms. Second one is once we get ready to review for the AP test, you can use your calculator, and you won't need to write all the work out. So we need to write out the work now so that we can remember the formula and know how to use it. But once you get to the AP test, you can use your calculator. I still need to show you the confidence interval formula and the calculator. Before I do that, though, is there any questions on the problem we just did? Greta?
Is it just the PC on the formula sheet or just like the bottom of the number?
So the formula sheet never has the entire formula for you. It does have the entire denominator.
But it doesn't have like the PC is like this one.
It does have PC.
Where?
So it has PC right here, and then it has the whole denominator.
Oh, so like x1 is like n times p.
Correct. X1 is the number of successes. Okay, anything else? Okay, let's write down the confidence interval formula real quick. Okay, confidence interval, like I said, does not use PC hat. It is P1 hat minus P2 hat plus or minus Z. Square root is the same except it uses P1 and P2, not PC. So it's going to be P1 hat 1 minus P1 hat over N1, and then P2 hat 1 minus P2 hat over N2. So the confidence interval is less work, in my opinion, because it doesn't have the PC. So that is what's hard to remember, is you do have to remember that for the hypothesis test, you use PC. For the confidence interval, you don't. The assumptions are the same. But do remember that there's a difference in the assumptions based on if it's an experiment versus an observational study. So again, in your homework, you will have one hypothesis test, one confidence interval.